Hi, we are Group 18. Myself, Samia, Smith, Mitch, Ayus, and Ethan. Today we will present on wind energy. This presentation is divided into 6 sections. We will begin with the introduction to renewable energy, a brief description of wind energy, role of engineers in wind energy, positive impacts of wind energy, ethical considerations, and last but not least, future of wind energy. For many decades, fossil fuels such as coal, oil, or gas have been major sources of electricity production. But burning carbon fuels produces large amounts of greenhouse gases which cause climate change and have harmful impacts on people's well-being and the environment. In this situation, renewable energy has come to rescue. Renewable energy is energy derived from natural resources that are replenished at a rate faster than they are consumed. The different types of renewable energy include hydro, wind, tidal, solar, and biomass. Currently, 16.3% of Canada's energy comes from renewables. Today, we will specifically focus on wind energy. Wind energy is produced by the kinetic energy from moving air that is converted into electricity by wind turbines. The majority of wind facilities in Canada are located in Ontario, Quebec, and Alberta. As governments and utilities across the world weigh the need for affordable, reliable, clean, and diverse electricity supply, they are increasingly seeing wind energy as a solution. However, the question remains, what makes wind energy an attractive renewable energy source? On a global scale, wind energy will help meet United Nations Sustainable Development Goal number 7, which is to ensure access to affordable, reliable, sustainable, and modern energy for all. On a national scale, wind energy provides affordable power. It is currently the lowest cost option for new electricity generation in Canada. Furthermore, when it comes to the reliability of the power grid, Canada can get more than one-third of its electricity from wind energy without compromising the grid reliability. On a local level, Saskatchewan is aiming to diversify its energy supply, for which it requires to include wind energy as a low-cost, emission-free way to meet the demand.
Now, we will be talking about the role of engineers in wind farm projects. Engineers are responsible for clean design, which is often described as the combination of appropriate technology and materials lifecycle. Engineering team consisting of many different disciplines, such as electrical, mechanical, and civil, work together for the success of wind farm projects. Engineers are responsible for monitoring energy-related design and construction, advising clients on sustainable design and energy conservation analysis. Engineers who work as project managers direct the implementation of energy management projects on a large scale. And lastly, field engineers are tasked with commissioning and following the commissioning checklist to ensure that the system functions as intended in the design. Engineers design wind farm systems taking into consideration of turbine length, orientation, and spacings. This process is called micro-seeding, and choosing the exact type of wind turbine and its orientation in the wind farm is an important aspect of the design process. There needs to be other considerations such as the noise emissions or shadow flickering of the wind turbines. Computer models can accurately predict where, when, and to what degree this problem will occur, so wind project developers can mitigate this impact during the site selection process.
Wind energy has the tremendous potential for positively affecting our markets, environment, and society. Wind energy projects are typically placed away from major urban centers and are commonly seen in more rural locations. The foreseeable impacts for neighboring communities include the potential for increased revenue in the form of land lease payments and an increased local tax base. Wind energy can also reduce the electricity rates of neighboring communities. Immediate impacts from building wind projects include manufacturing, transportation, assembly, and maintenance jobs. As of 2018, more than 114,000 full-time workers were employed in the wind sector in the States, and in Canada, more wind energy has been built between 2009 and 2019 than any other form of electricity generation. The addition of wind energy to any market will help diversify its energy sector. Wind energy has a relatively small footprint and can allow crops to grow and livestock to graze close to the base of the turbine. Wind energy is a form of sustainable energy, climate depending, and presents a form of energy production with very little environmental impact while in use. There is also the potential for wind energy tourism to emerge from areas surrounding wind farms. As more advanced forms of green energy emerge, a potential delayed impact is the increased awareness and further education of the public regarding this technology. To date, the research and valuations conducted overall conclude that wind turbines are not harmful to human health.
Wind systems have negative impacts on the environment. Birds do collide with wind turbines. While the rate of deaths caused by wind turbines is minuscule compared to other obstacles humans put in their way, it is still an issue that can cause concern. Also, people's perceptions of the aesthetics of wind farms are important in siting the machines. A few simple considerations have emerged, which can make them much more acceptable. Arranging same-sized turbines in simple, uniform rows and columns seems to help, as does painting them a light gray color to blend in with the sky. Noise from a wind turbine or wind farm is another potentially objectionable phenomenon, and modern turbines have designed specifically to control that noise. In order to address such ethical issues, CSA Guide to Canadian Wind Turbines Codes and Standards specifies multiple specific codes and regulations within zoning, public hearing, building permits, electrical permits, acoustic noise, and foundation for engineers to follow.
This chart illustrates historical and projected wind energy capacity in Canada broken down by province. Total wind energy capacity in Canada grew strongly from 11,670 megawatts in 2016 to 15,506 megawatts in 2020. Growth is planned to stay consistent between 2020 and 2040, with average annual capacity additions of 200 megawatts. The majority of the growth occurs in Ontario, but substantial increases also occur in Quebec and Alberta. Total installed wind power capacity increases twofold over the projection period, reaching 19 gigawatts in 2040. The share of wind generation increases from over 2% of total electricity generation in 2014 to close to 5% by 2040. We engineers have a big responsibility in the future of wind power. Incorporating a large amount of wind energy requires continued innovation to improve efficiencies, extend turbine lifetimes, and mitigate interconnection problems. By encouraging the growth of domestic wind energy expertise and the development of wind energy technology relevant to the Canadian environment, engineers can help Canada realize many business, economic, energy, societal, and environmental benefits.